So now in this module, we are going to learn more about the building blocks of the programming. And this is the most important concept when you are going to come and write your own program for a program. So with that in mind, let's see what can be the building blocks. And these are the backbone of a parallel program. So first of all, let's introduce with new terminologies, which is threads and a process. Threads and process. So, what is the difference between this? So, first of all, when you see the threads, so threads are actually smaller execution unit. Okay, and this is the thread which is within the process. So, threads are something which is within the process, and they share a memory and can run concurrently. So, they share memory and runs concurrently. However, the process, so process are independent program. So process is an independent program and it has its own memory space. So in a short way, it could be, you can imagine as this. You have a memory block. In this memory block, if you are running a process P1, it would be having its memory block here. There may be a process P2 containing the memory block this and P3. However, then imagine a thread. So there could be a multiple thread at place. So there can be a thread T1, T2, T3, and this all shares the same memory space of a process. Similarly, let's say there is a thread T1 dash, T2 dash, and this shares the common memory space of a process. So this is the essential difference between the threads and process. So with that in mind, let's see. So these are just the building blocks of a terminology, which are threads and process. The another terminology which would come into mind is synchronization. So when you're running anything into the parallel, what can be the issues you may face? You may face that there may be issues when you're running the concurrently. You may get a race condition. There may be overriding of the data. There may be a memory leak or lot of issues which can happen. So eventually this becomes with the lack of a synchronization. You can assume like that if there is a thread one and there is a thread two, and in case that if the both are working on a same memory space M1, then if thread 1 has accessed the memory, and thread 2 is also accessing the memory, and if the result is supposed to write back onto the mem2, so thread 1 writes back, then thread 2 writes back, and when the thread 2 writes back, it has been overridden. Now, if someone on let's say thread 1 itself try to read back the memory, and thread 2 tries to read back the memory. So there is a memory, thread 1 which is expecting is a different, thread 2 which is expecting is a different. So these are the scenarios which needs to be avoided. This can be avoided by the concept of a synchronization. So how we can design the synchronization? First of all, first way is to place a varied block, or you can call it as a mutex. Now, what does this lock or mutex does? It's that It prevents the multiple threads from accessing a critical section simultaneously. Now, what we can do is, let's say this memory, this block of memory is being supposed to used by the multiple threads. Now, what we are trying to say is we will define this memory section as a critical section. Now, when we do this critical section, so in case that the thread 1 is accessing this section, so thread 2 must wait. So thread 2 will not access this memory until and unless thread 1 has finished. And this mechanism has been known as a lock. So you have locked the memory to access by any other threads. Another concept to achieve the synchronization would be with the help of a semaphores. Now, what is a semaphore? So, semaphores is when you are trying to limit the number of threads that can access the shared resource concurrently. So, what you are trying to say is that you do have shared resource. Let's say it could be memory or it could be a storage. But what you're trying to do is at a time, only a certain number of threads can be allowed to access this, not all. This process is known as a semaphore. The another mechanism which you may see that widely used is called out as a barrier. Now, what does a barrier do is it forces the threads to wait until all have reached a specific point before continuing. So, what we are trying to do is, let's say there is a thread 1 which is running some process. There is a thread 2 which is also running the process. There may be a thread 3 which is running the process. Thread 4 also running some process. So what happens when we add a barrier? So let's say when we add a barrier, say this would be the barrier. Now, with the help of this barrier, what happens? That until and unless all the thread results are collected, maybe it's ended earlier or later at the point of time. But until the all thread values are collected, the process of execution will not go further. So you executed this 4 threads in parallel, but till the substrate instruction. Now, until and unless the report with all the information here, it cannot be start continuing the execution. This is called as having a barrier. Now, as we already covered in last session about the hardware level parallelism, that is nothing but the memory models which you would need to know for parallelism and how you can interact with it. So when you see the memory model, so you have two kinds of memory, which is a shared memory and a distributed memory. In the shared memory, all the threads or process have a direct access to some common memory space. Whereas in distributed, each process has its own memory space. Data is communicated through the message passing interface. Now, this was about the memory model. Now, when we discuss about the distributed memory or heterogeneous computing, the other things which comes into the picture is the communication models. So you need to communicate between the processes also. So the communication model which would be most popular would be that message passing. So what happened in this message passing is that a process communicates by sending and receiving the messages, which helps in decoupling tasks and managing the data exchange robustly. Each of these components plays a vital role in ensuring that parallel systems operate efficiently and correctly. So, this would be the fundamentals of the building blocks of a parallel program.